In this next example, we're going to look at a file upload utility that allows a client to upload files to a server. It's going to help for us to have a general overview of what this program is going to do first, and usually a sequence diagram is helpful in these types of scenarios. This sequence diagram looks at an application layer view. So this is above the transport layer. So we are going to ignore handshakes. We're going to ignore acknowledgements. Once the client and server are connected, the client is planning to upload a file. It first sends the link for the file. And this is going to be useful because otherwise the server would not be able to tell the difference between data that is very slow on the internet, so if you have high latency, and the end of the stream. Okay, so we send the link first in order to tell the server that to expect this many bytes. When the server is ready to accept these bytes, it's going to send a message ready to the client. And our assumption is going to be that both of these messages are only going to be a single chunk. And there are ways to remove this assumption. You have a fixed size header that you attach, and that header is going to have a checksum inside of it. This is going to take a lot of additional code, so we're not going to implement it. And instead, we just assume that the length gets sent in a single chunk, which is a generally fair assumption. The largest integer that JavaScript can handle is only 16 bytes after being converted to a string. Once the server has sent the ready message, the client will begin streaming the file over. So it's going to receive multiple chunks, might be a couple hundred, might be a couple thousand. Every time we receive a chunk, we're going to take the size of the chunk and add it to a running total. When that total exceeds the value of the length that we received, we are sure that we've received the entire message, and so we can send back a file received reply, and we can begin the four-way closing handshake. Let's start with the client. The client is sending a message to localhost on port 3000. We are going to be uploading a file, input/small.dummy. And if we look at this file, it's just a bunch of zeros and ones. We are going to get the length of this file using fs.stats, which will just give us sort of metadata about the file. Then we're going to create a read stream on that file so that we can pipe it to the server. When the server connects with our client, the connect handler will be triggered, and this will initiate the file upload. So the first step of the file upload is to send the length over to the server. So we're going to socket.write, and the length of the file is going to be the length value over here that we extracted out. This is of type number, so we are going to convert it to string so that it can be written to the server. On the server side, we have a receive length function, and we use socket.once, which means that we're only going to be listening for this data event a single time for this particular connection. Receive length will take in a chunk of data. Again, that's what's transmitted over here, representing the length. And it's going to convert it back to a number. That's going to be the total length of the file that we're trying to download. It prints it to console, and then it sets up a listener to start receiving the data. So this allows us to change the behavior of what happens when we receive a onData event. On the very first time, we're going to use socket.once to receive the length. Inside of receive length, we're going to change the behavior such that it calls the function receive data from now on. And then it sends back a message to the client, socket.write ready. Here we have what happens when the client receives messages. The data handler will first check to see if the message that we received is the ready message, and it's going to start sending the file over. So we have our file stream that's already opened, and we're going to pipe it to the socket. This file stream will eventually exhaust because there's only a finite amount of data. If you leave out this flag, it will send a fin request to the socket, which will terminate our connection right away, which we don't want. So if you want to keep your connection open after you finish sending a file, include this second option variable. When that file stream is exhausted, we will print a message, all data sent, to our console. Let's jump back to the server, who is now going to be receiving the data. It's going to receive one chunk at a time, but it also has available to it the total length of the file expected. We have a socket level variable transferred. So this is scoped to when the socket was created. And this reflects the number of bytes that was transferred between this particular server and client. We also have a stream variable, a writable stream, reflecting the location where we are going to place the saved file. So once we receive a chunk, we're going to take the length of that chunk and add it to our variable transferred. And because this variable is scoped on the socket level, each call to receive data will use the same transferred variable. We then print a message. Scroll over here a little bit. So it's console.log new chunk, and then we print out the length of the chunk, and then we print out how much was transferred so far. So we could sort of see a progress of how much data was transferred. Written takes in the current value of transferred at the time of receiving a chunk. And the reason that we have to move it into this separate variable is because when we do output file that writes, this is a asynchronous function. So we don't know when this is going to occur. And if we pass in instead of written, if we pass in transferred, it's going to be a different value because at that point in time, we might have received more data. We're going to call finish writing using this variable. And this is going to sort of keep track of when we've received all the data. So all this finish writing function does is check to see if the number of bytes written is greater or equal to the total length. And if it is, then we are going to send an end event to the client. Okay, so that corresponds to this location. So once we've received the very last message, we will send a message file received to the client, and then using socket.end, we will terminate that connection. On the client side, if it receives any other message that does not include ready, it's going to print that message to the console. So next, let's look at this program running. First, we'll start the server. And when we start the client, it will immediately send the file mol.dummy. Okay, so first it connects and initiates the file upload. This file upload will appear chunk by chunk on the server. So first it receives the length of the file, 524,000. Each chunk of data it receives will update sort of this progress. And then when the client finishes sending all the data, it will pop up the message all data sent. The server, upon receiving all the messages, will print a message file received, and then we'll send that message to the client. The clients will receive the file received message, and the server also send a socket.end to terminate the connection. We can see that the client also received the end, and that will terminate the connection. So let's look at what Wireshark has. So there's a lot of segments here. So first we'll look through segments 1, 2, and 3. That is our three-way handshake. And over here we can see that the client initiates the connection. And the way we can sort of tell that is by the high number port. The high number port typically belongs to the client machine. So this port number is 64,858. That is in the ephemeral port range. So we can see that the client initiates the connection with the server, and server responds back. And the third segment is the end of the three-way handshake. At that point, the client, okay, high number port, will send a message to the server. This reflects the length variable. If we go back to our diagram over here. So the client is going to send a length, and that reflects segment 4. Segment 5 is the acknowledgement of that length. Segment 6 is the server sending back the ready message. And segment 7 is an acknowledgement of the ready message. Starting from segment 8, we're going to start sending zeros and ones over. And the order of these is not guaranteed anymore, okay, because the server is trying to send a large amount of data, so it's going to do it as efficiently as possible. So over here we can see that the server is sending 2 segments, and then one of those get acknowledged, and then 2 more of these segments, and that's going to be controlled by the window size. Eventually we're going to jump down to segment 34. All the data has been received on the server, and so the server is going to send back one last message, file received, and at the same time it's going to begin the closing handshake. Okay, so we can see that the server is sending the message file received. This message gets acknowledged, and then immediately afterwards we begin the 4-way handshake to terminate the connection.